Welcome to the new problem solving session. And we are talking here about the graphs, oscillation graphs. And you can see the problem at your screen. I would advise you to read the problem slowly and try to understand it. The statement of the problem says a weight m, that is mass m, falls from a height h onto a platform attached to a spring with a spring constant k. Well, you can make your picture in your mind like there is a platform, there is a spring fixed at some support, and there is a block of mass m, height h above the plane, and this spring and platform are massless, and motion takes place along the vertical. That's right. Draw graphs of the acceleration and velocity of the weight as a function of time. So the graph is already drawn, you can see at your screen, but think about this. The graph is drawn by taking the coordinate axis x downward, and I have placed the origin where the platform is located with the undeformed spring. Remember, a spring will be undeformed, and here is the origin. A spring will be undeformed in the beginning because no mass is in contact with it. And now we draw graphs of the velocity and acceleration of the mass on this axis depending on time. You can think, before hitting the platform, the motion of this mass is uniformly accelerated with acceleration g, you can see here. And after impact, it moves first downwards and then upwards, and its acceleration decreases, comes to a maximum because it is under simple harmonic motion. It is performing a harmonic oscillation with frequency, omega equals under root k by m simply, and its equilibrium position is mg by k. This is not shown in the graphs because acceleration, and these are acceleration and velocity graph, so position is not particularly mentioned, but we know the equilibrium position of this oscillation will be mg by k. And then it breaks away again from the platform. The weight again flies with acceleration g until the next impact in the air, and the whole process is repeated. So you can see here the acceleration is initially constant and then decreases and increases again and becomes g again. This is the whole process of acceleration with respect to time. And what happens with acceleration, you can relate it with velocity, because when the velocity is maximum, when the acceleration, when the object comes to its equilibrium position, when its acceleration is zero, its velocity is maximum, and velocity first increases in negative downward direction and then increases, and you can see the whole process here. If you want to calculate something, you can also calculate it. That means using mechanical energy conservation, you can calculate the maximum value of x that is its displacement from the undeformed position of the spring by writing the mechanical energy conservation and putting the datum at this position as well, where the potential energy will be equal to 0. You can simply write its initial energy was completely potential, so you can write here mgh, and that is equal to half k max square minus gravitational potential energy, because when it comes to rest, its velocity becomes 0 again, and its x max, its velocity will be equal to 0. So you can write here minus mg x max, and you can get your x max from here. And of course, the amplitude of oscillation will be x max minus x naught, that was mg by k. X naught was mg by k, the position of equilibrium when the mass was in equilibrium. You can find it as well, and accordingly you can find a max, that will be simply omega square a, and the maximum speed of the object, simply b max, will be omega a, and you can get all those values if you want to. The graph you can see here, it's simply this. Try to focus on the graph and learn this. Thank you very much.